Good afternoon. My name is Iain Wight. I'm the Business Development Director for Williams Advanced Engineering. Over the last few years, we've seen some seismic changes in our industry. We've seen disruptive technology and we've seen legislation forced upon us. This has had quite an effect on our industry, so I thought the title of the event today was very, very apt to describe, are we actually on the road to nowhere, or are we actually in the most exciting time that we've ever had for years? So I'm not going to try and answer that question now. What I will do, though, is share some of our experience through a video for the next few seconds.
At Williams Advanced Engineering, we bring the same advantage to our customers and the world as our cars. We do this by thinking differently, looking to the future, with rapid innovation, to produce inspired engineering that enables a sustainable future. Williams Advanced Engineering. Advantage engineered.
As you can see, there's a number of automotive programs in there, but there's a lot of diversity within there as well. Now, we know change is coming. It'll come whether we want it to or not. We in the automotive and motorsport industry, we are one of the most agile industries in the world. If some of the challenges that we were facing were being put to, say, the marine, the shipping or the aerospace industries, it'd probably take them about 2 or 3 years to actually get sat around the table. In that time, we will have addressed the problem, we'll have found a solution, implemented it, and moved on. So to be more specific, what does this change mean for us, and what are we going to do about it in the near future? Somebody touched on earlier that we make 2.7 million engines in the UK every year. We export around about 54% of those engines. That tells me that we have a level of competency in this country, not just on manufacturing, but also in our whole supply chain. Now that's really special because we've got something that people actually want to buy that is class leading, thinking of the export perspective. By 2040, the internal combustion engine will become a real part player in where we will be in the future. There's a race going on to see what will take over from a powertrain point of view. Just now, the electric motor and the battery system are the main contenders for that journey, really. So how are we going to get there? How are we going to make the transition over the period of time? What we need to do actually is have a little look back at the history of the car. Now, we've been through levels of this transition, not once, but actually twice before. What you have to think about is a time before cars. In an average city centre world, in major city centres, we had a problem before cars. The concentration level of horses was around about 500 horses per square mile. Now, if you think we've got an emissions problem today, think about it then. Every horse emitted about 20 kilograms of manure and a gallon of urine every day. 500 horses per square mile. That's quite scary to me. And you can see the introduction of the horseless carriage would be welcomed at that point. To give you an indication of it, the picture here shows Fifth Avenue at the turn of the century. Not many cars on there. You only actually have to move forward just more than a dozen years to see the level of change in mobility at that time. Now, what we're facing today is pretty serious, but it's not as serious as that. Let's have a look back at the history side. What a lot of people don't know is that the first 20 years of car history was actually electric. Electric was safer, it was quieter, it was better for the city centres. Petrol-driven engines were noisy, they were incredibly difficult to start, and they were pretty dangerous as well, because you were riding around on this big bag of fuel, which was quite dangerous, really. What changed that, though, really 20 years on, was, ironically, the electric motor, because it allowed easier starting of the petrol engine. And a certain Mr. Ford, who came along, who actually devised a method of producing petrol engine cars very cheaply. And that completely killed the electric vehicle at that time, probably for somewhere between about 80 to 100 years. We've seen some great pioneering work when we look at the next generation of electric vehicles that has been done by Nissan, by Tesla, by Toyota and other car manufacturers. Now, there's probably not a car manufacturer in the world that I'm aware of that does not have an electrification strategy in their future engineering strategy. But how are we going to get there? No one person is going to have the answer. It's going to be a collaboration between a number of different bodies and companies over time. When you think about it, gasoline fuel, has around about 50 times more energy per kilogram than a lithium-ion battery. That's fairly serious. Now you can recover some of that because of the efficiencies that you get from an electric system. But we're still going to rely on industry, academia and government to develop this technology to bring the energy density levels higher than they are. Companies like Williams will fit into this. We're a small player in this market, but we will drive an element of this technology forward through the application. The APC is a huge help on this because they help guide us as an industry. If you don't know where the answers to these are, they are actually all on the APC website. Roadmaps for showing future direction are pretty accurate. There's been a lot of work done by the Automotive Council and the APC to be able to outline what we are going to go through over the next few years. We will see a huge change within energy storage. We'll see a change to the infrastructure, how cars are parked, how they're charged, how they're maintained, will all change over the next 20 years or so. Hybrids will allow us to transition from a pure gasoline or diesel engine through to a full electric vehicle. One of the main things, though, will have an emphasis on performance. The focus on energy density and range is very real. So therefore, lighter weight vehicles, more aerodynamically efficient, will become a real theme for the future. So how can we as Williams help in this? You're possibly a little bit more familiar from Williams from the Formula One point of view. In advanced engineering, we're fortunate to have the benefit of some of that real leading edge engineering and systems that we've been applying into different sectors now for a number of years. This has enabled us to do certain things, such as reimagining and engineering how an electric vehicle platform would look. Now, we've had this release for around about a bit over a year now. It's very relevant, though. You've got to think of this not just as an automotive platform, but it's a mobility platform for nearly any type of sector. What it does is it provides a lightweight structure with a lot of integrated systems within it. So the battery system, for example, is not just a passenger, it's a structural member within the vehicle. The cooling system provides dual usage through the structure of the vehicle as well. When it's all combined, it will make up into a vehicle that's significantly lighter than anything that's on the road today. And there are elements of this that have been developed and taken forward, such as a zero loss process of carbon fiber manufacture for wishbones, for example. That's one application. But it's a process that will generate a carbon fiber wishbone 40% lighter than aluminium at a similar cost to a cast aluminium part that can be taken into volume production. We've done a similar thing with the battery exoskeleton, where you take a two-dimensional carbon fiber structure and turn it into a three-dimensional carbon fiber structure. capable of being manufactured in volume at a rate that's suitable for automotive production. Now, we have a vision of the future that maybe isn't so far away, but a carbon fiber type pod where you can actually press it in the same way that you would press a steel component and then fold it into shape after you've fitted the internal parts in it and go through a secondary curing operation. We've used our knowledge taken from motorsport. If you think about what Formula One went through in 2009 with the introduction of the carriage system, that gave us a lot of knowledge on electrical systems and battery usage and energy deployment in a high-performance environment. We took that and applied it into Formula E, having equipped every car in Formula E with a battery system so far that's been racing through the last 4 seasons. And we're now applying this into a lot of high-performance vehicles and actually quite a range of vehicles, not just high performance. That's moved us on to the next step of the journey, really. Remember, I touched on the 2.7 million engines. Just now, we only make a handful of batteries in the UK, very much in low volume production, prototype type areas. Through our work with Unipart, we've set up a battery production facility that will come online later in the year with a capacity at around about 10,000 units per year. This technology is not only relevant to the automotive industry, it's relevant to many other areas of industry. Our first customer for the Hyperbat facility, for the battery production facility, will be Aston Martin. Now, they've taken on the electrification aspect, and as a small manufacturer, that's quite a difficult task for them. It's pretty obvious, especially if you read a comment from one of the major German car manufacturer CEOs recently. His comment was that he was concerned with the introduction of new technology on such a mass market scale that if they have a big warranty or recall situation, it could be incredibly damaging for their company. A company like Aston Martin, they needed to be able to take a vehicle into production quickly. They didn't want to do a new platform for that. They wanted to base their first introduction on an existing platform. So we took this vehicle, replaced the V12IC powertrain with an electric powertrain. That enabled them to save on the development point. It also allowed them to restrict the numbers going forwards. The numbers are limited on this car to 155. So it gives them a first chance, really, to test out the market for an electric vehicle on a radical change of technology and keep it controlled, which is very important, I think, for the car manufacturers. We have to be awfully careful as to how we move forward through this space. Now, we've applied this technology not just in the automotive sector. We've applied it in aerospace and space, powertrain systems in marine, lightweight structures into healthcare, and I struggle saying this, but aerodynamics into the grocery industry as well. So there really is no limit as to where this can go. So the question really was, are we on the road to nowhere? No, I don't think so, actually. I think we're pretty much in pole position for leading this charge now. I think that we have some incredibly good technology within the UK, I think the opportunities are there just now to grab the market space and become world leaders in this. If we do it properly, we could even make ourselves pretty well Brexit-proof over the course of the next few years. The starting signs are good, so let's go and get it. Thank you.